Today we're going to be talking about solving inequalities. And inequalities are solved just like equations. Just unlike equations, we're going to have an infinite amount of possibilities for our solutions. So our first example, I am going to subtract the 4y over, and I'm going to subtract the 2 over, so that we end up with negative 5 less than y, or flipping it around, y is greater than negative 5. So graphing the solution on the number line, you go to the value negative 5. Since it's not inclusive, it's an open hole. And since y is greater than it, that arrow there tells me all of my possible solutions. Now there's a new type of notation that we're going to be using a lot this year, and it's called set builder notation. And it has a bracket, and then your variable, a little line, and then the inequality. And what that means is y, your answer is y such that y is greater than negative 5. And we're going to be using this a lot when we get into later chapters, so I'd like to introduce this to you guys now. Okay, solving this equation, and I have a little reminder here. When we multiply or divide by a negative, we must switch the inequality symbol. Now, I'm going to do this one all without a calculator. Remember, that decimal as a fraction is negative 3/10 p. Now, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by negative 10/3. Don't forget to switch that inequality sign. When I multiplied by 10/3 over here, or negative 10/3, that canceled out that fraction, so I'm just left with p. So now that makes our life a lot easier because the 3 and the 12 cancel to be a 4, and I get negative 40 less than or equal to p, or p is greater than or equal to negative 40. Okay, so I give us our number line. Now we need to think of an appropriate scale for the bottom. Negative 40 is a pretty big number, so I might go by 5s. So I'm going to go, if I go by 5s, if I number every other one, that's going to tell me that I'm going by 5s, but I'm not writing as much, which is kind of nice. So it tells me that each one is going by 5s, but I'm not writing as much, so we don't have to worry about taking up a lot of space and it looking messy. So p is greater than or equal to, so greater than or equal to filled in dot, going that direction. Now again in set builder notation, p such that p is greater than or equal to negative 40. Okay, our next example. Let's distribute the negative through, so we have a negative 15d plus 35 greater than 6d plus 42. Now I'm going to add the 15d to both sides so that my coefficient in front of my variable isn't negative. So if I add 15 to both sides, we get 21d. If I subtract 42 from both sides, we get a negative 7. Now divide by 21. Now be careful here. A lot of you guys are going to say that's negative 3. It's negative 1/3. Writing it so that the variable's on the left, okay, so it's numbers less than negative 1/3. Okay, so let's make that 0. Let's go by thirds again. This would be negative 1. That'd be negative 2. Negative 1/3 is there. It's an open hole, and I'm less than, so I'm going to the left. Okay, as I was talking about earlier in this section, there's two special types of notation that really leaving this class I want you guys to know. Set builder notation we're going to be using a lot in later chapters when we talk about these things, domain and range. I've kind of already talked about that. But interval notation is putting numbers in between essentially brackets or parentheses. When you put a number in parentheses, means it is not inclusive, meaning I don't count the points that are on those endpoints. When we have it in brackets like that, means that I do include the endpoints. So looking at this inequality is x is greater than negative 3. As we already talked about in set builder notation, it's x such that x is greater than negative 3. Set builder is kind of easy because all you have to remember is that it's these types of brackets. Now, in interval notation, you're giving me essentially the interval for x. We use a parenthesis because we don't include negative 3. So it's just negative 3, comma, and then our endpoint, it goes on forever, so that's going to be positive infinity. So this is not a coordinate. What this is that's the start point. Okay, it tells me that our interval starts at negative 3 and goes forever to infinity, which is an endpoint. When putting things in interval notation, parentheses means I don't include those endpoints. This negative 3 is not part of my solution. It's not because it's an open hole. Negative infinity we can't, or positive infinity even, we can't include because they're not values that we can stand on. So for infinity, we always have parentheses in there. Okay, this next example, x's are less than or equal to positive 1. So again, our set builder notation is easy. X such that x is less than or equal to 1. Now, interval notation. You could think about it as this value there. I think about it as a start point or the smallest value. What's the smallest value that's part of this solution? Well, that's technically negative infinity. What's the largest value? Our largest value is 1, and we stop at 1. So I actually have an incorrect notation back here. It's not a parenthesis. It's inclusive. I'm including 1, so it's a little bracket that looks like that. So it tells me, this notation here tells me that our answers are from negative infinity to 1.
Now we're going to talk about solving compound inequalities. And compound inequalities contain the word and. And means both the inequalities are true. Okay, so the numbers that x is greater than or equal to negative 4, less than or equal to 3, is everything in between. And down below here, we have a compound inequality. And what you can do is you can add 2 to every number so that I have a 12 less than or equal to 3y less than 21. And then if I divide everything by 3, we get 4 less than or equal to y less than 7. This is a fancy way to write a compound inequality. I think about it as a sandwich. Y is sandwiched in between 4 and 7. So in between 4 and 7, everything in between there. And see how that kind of looks like that graph above. Remember, and means both are true. Now with an or, okay, when we have an or, one or more of them are true. Okay, so it's either this one is true or this one is true. So when I subtract 3 from both sides, I get -1. Or I divide by a -1. Remember to switch your sign. Okay, x is less than -1. Or, that's actually a +4. Or x is greater than or equal to, so it's a filled in hole, +4. Okay, so either one of those possibilities are true. And there's no shorthand for writing it or. Shorthand. Okay, there's no shorthand for this. It is one or the other. With an and, there's a shorthand for it. Now with compound inequalities, there are some special cases. Now let me graph these inequalities. Less than 2 is everything this way, and greater than 4, everything this way. I didn't shade anything that's in common. Remember, I need something that's going to make, when it's an and, both true. So making both of those true, I didn't shade over any piece. So this is no solution. So that's why a graph is going to help you out sometimes. Let me jump down here to number 4 and let's look at this different and possibility. X is less than 2, I'm sorry, greater than 2. And, remember it's an and, so both true. What numbers make both of those true? Greater than 4. And you want to think about, where did you shade twice? Okay, what numbers make both true? The numbers that make both of them true are the x greater than 4. So that would be your answer there. Okay, because all of those numbers make both of them true. If you look at 3, 3 is not greater than 4. Okay, so it's nothing in between 2 and 4. Okay, so you pick the larger, technically, of them. Now with an or, we are greater than 2 or less than 6. Okay, what have I shaded twice? Okay, what numbers make one or the other one true? This ends up being all real numbers. Okay, greater than 2, greater than -4. So which one makes one or the other one true? So which solutions make one or this one true? Okay, well, all of these numbers between -4 and 2 are a possible answer for one or the other one. -3, -2, -1, all these numbers in here are definitely greater than 4. So our answer here would be greater than -4. So some examples involving these special cases. So solve the inequalities like you normally would. Since the 2 is being multiplied, we can divide it by both sides, and we get x minus 5 greater than or equal to 1, x greater than or equal to, we add 5 to both sides, 6. Remember, this is an and statement, so I need to think about what possibilities make both true. So I'm greater than or equal to 6. Greater than or equal to 6 is right there. So then we also want to look at this example. Okay, let's subtract 4. So that leaves me with a negative 3. 3 minus x greater than, when I subtract 4 I get 0. Now if I divide by negative 3, we get 3 minus x greater than 0. If I add x to the other side, x is less than 3, so x is less than 3 is this piece, and I purposely did those in 2 different colors. Okay, what solutions make both of those true? X is greater than 6 and x is less than 3. Well, there's nothing that I shaded twice. Okay, with an and you pick the points or the inequalities that you've shaded twice. So this would be a no solution. Next example, solving our OR. I'm going to subtract the 4x over to get an x. I'm going to subtract the 3 over to the other side. Remember, this is an OR. So I am greater than negative 3 Now solve this inequality. I'm going to subtract the 1 over and distribute the 3 at the same time. I'm going to add the 2x over. I'm going to add the 6 over. Now we divide by 5, so x is less than 1. Now this is an OR, so which numbers make this one or this one true? I've shaded everything twice, so that ends up being all real numbers. There are your lesson questions. Please make sure those are submitted on time.